Furthermore, we can really glance such a long way out that we can see practically back to 13.8 billion years ago, which is extremely close to the Big Bang. We now know how our reality ends. Our fondness with science fiction movies and maybe the Bible would highlight the large bat end times, but imagine a scenario in which we told you that the end of the universe is the same as its beginning. The James Webb Telescope has uncovered that the universe has stopped expanding. Well-known researcher Brian Cox made this prediction a long time ago. In doing so, he gave us the most sensible starting point to envision the apocalypse. We can hope to light that started its journey before there were galaxies, and that is the oldest light in the universe, which is, by the way, one of the bits of evidence for people who try not to believe in the Big Bang. The response is, well, you can see it. We're going towards Big Bang 2.0. Join us as we explore why the world has stopped growing and James Webb's alarming revelation. If we're sure about anything in our understanding of the universe and its history, it's the reality that our extremely grand existence is unified around this event called the Big Bang. Of course, there are alternative theories that recognize the start of the universe, like eternal inflation or a wavering universe. But we're not getting into the validity of these hypotheses today, mainly because the galactic community has now readily accepted that our history in this universe begins with a Big Bang, and the ideas that succeed the Big Bang are likewise based on the same normal place of a universe's birth. While the Big Bang is a well-known word in the theoretical knowledge of cosmology, in space we're barely aware of the details and the place of the singularity, unless you're a geek who spent hours watching some brilliant representation of the Big Bang. To be fair, the singularity was more than an explosion, or so to speak. Essentially, the Big Bang finds its origin in a single point, a point that was vastly hot and thick and swelled to extreme lengths. All of this was when the universe was inconceivably young. Believe it or not, at the time of the Big Bang, the universe was only 10 to the power of minus 34 seconds old. That is 1/100th of a billionth of a trillionth of a second in age. This is when the universe experienced an incredible explosion of expansion, also known as the infamous inflation. During this process, space expanded faster than the speed of light. No doubt, you could never have even blinked when the universe grew multiple times in size, nearly instantly, from subatomic size to golf ball size. 1 second after the expansion, the universe began to cool, and that led to the formation of matter as we know it today. No doubt, similarly as the timeline goes, in less than a second, our universe was filled with every particle we've learned about in our science class. Protons, neutrons, electrons, positrons, photons, and neutrinos are the legacy of the Big Bang. Mystical, right? Well, allegorically, it seems like it, but our understanding of the universe's origin is deeply theoretical. We've come a long way since the first moon landing, and since then, our technological progress has developed dramatically. Back when scientists were studying the Big Bang only based on mathematical equations and scientific models, they could never have imagined that we'd investigate the possibility of life on Mars. There have been some large breakthroughs in our interests to study the universe and explore space. Yet, even then, our current technology is pretty limited. You see, we can't reproduce the Big Bang or peer back at the event itself. Our greatest piece of evidence comes from the cosmic microwave background, which has allowed scientists to observe the echo of the Big Bang. While this method is crucial in the study of the universe, it's also theoretically limited. The greatest barrier in this specific approach is the fact that we can't see the gravitational waves or the leftover radiation that came from inflation itself. So, while our whole knowledge relies on theoretical principles, scientific hypotheses still have plenty of room to be refuted. And that's right, we're almost certain about the Big Bang as the concept and how it was fundamental in creating our universe. However, there are some pieces of repercussions we've misunderstood. Also, though surprising as it may be, theories about our universe are largely based on data that is prone to human errors all the time. At the same time, some of our data is also quite convincing about the Big Bang. Now, let's just state that, in time, it's difficult to refute the hypothesis outright. In the past year or so, our only redeeming quality to study the Big Bang was the Hubble Space Telescope. And now, of course, all bets are on the magnificent accuracy of the James Webb Space Telescope. Before we got to use these powerful technological instruments, one of the greatest disputed matters in galactic review was the expansion of the universe. If you pick some science textbook from the mid-90s or so, you'd read about how the universe is expanding. At the end of the day, the universe is expanding, and that's one little scientific truth that we've clung to. But the real mess here is that maybe we don't know what the expansion of the universe actually involves. More importantly, we need to ask whether the universe is actually expanding because, heads up, the James Webb Space Telescope is telling us otherwise. An amazing miracle, the universe has stopped growing. And hey, while the world is still perfect, you might want to improve your web experience, safe and secure, because we surely have to. This is why we're happy to reveal our own personal secret. To get reading and access deep content, make some heavy, useful recordings. Today's video is supported by the boss of safe and accessible web, Atlas VPN. With more than 6 million clients globally, Atlas is changing the game for everyone. Okay, this service won't be available in space, but Atlas would make your web experience very secure and speedy. Can't watch shows that are locked in your region? Connect to Atlas in a microsecond. Presto, you're in. You don't need to be a tech expert to use this service. It works for everyone, and all that for just $1.83 a month, plus 90 days extra. So why choose Atlas? Atlas VPN kills malware attacks, keeps your searches secure, unlocks content from all over the world, and offers the best deals on the market. You can get all of this for all of your devices via a single subscription. Grab the amazing deal because now Atlas VPN Premium is just $1.83 a month, plus 90 days extra, and with a 30-day money-back guarantee. Protect your privacy and get all the benefits of Atlas VPN at a ridiculously low price. You can take this deal by clicking the link in the video description below. Be quick, as it's a limited time offer. So, while we thank Atlas VPN for supporting this video, click the link in the description to take advantage of the limited time offer. Your web experience just got a lot better. And now, before diving into the implications of this monumental shift in our universe's direction, let's just discuss our understanding of this astounding phenomenon. In the front of the rest of the competition, the most commonly known information related to the Big Bang describes it as an explosion. Well, fiction and popular media have attached strong imagery to this process too. Any piece of media would describe the initiation of the universe as some kind of fire that flung lots of energy and matter, just spreading in every direction. Logically speaking, that kind of perception is incorrect. Regardless of the widespread use of the word explosion and the expansion of the universe, the birth of the universe wasn't exactly an impact. Researchers believe we need to address how we might understand the universe. In NASA's own words, the universe didn't just venture into space as space before the universe. Rather, it's better to think of the Big Bang as the concurrent appearance of space everywhere in the universe. Our understanding of the singularity also reveals that our universe has lived through a powerful infinite period that was only interrupted by reionization in space. Before that specific chemical guess, our universe was simply pitch dark. The let there be light moment of the universe happened 400 million years after the Big Bang. That's right. The Big Bang only made the basic building blocks of all living creatures and heavy bodies in the universe. For 400 million years, the universe was plunged into darkness because, well, it's simple, there were no stars or galaxies. When that was corrected, as clusters of gas transformed into stars and galaxies, the universe finally emerged from its vast, dark ages. So, here's a little random fact for you. When do you think our solar system came into being, assuming the universe was just darkness and eeriness for 400 million years? Well, our solar system was born 9 billion years after the Big Bang. No doubt, sorry science fiction movies. There's a huge disconnect between the supposed explosion and scientific theory, and of course, this changes everything. As things stand, our universe still exists as a singular initiation point. It hasn't moved or expanded since the Big Bang. What really happens is that space has been expanding from the start, and it carries matter with its direction. To put it in simple words, the universe isn't growing the way we imagine it, or indeed even understand it. It's actually the dynamic expansion of space that precedes the expansion of the universe we know. It's a bit complicated to understand, but it's important to grasp the implications of what we're about to tell you. For the sake of this video, we continue to use the term expansion of the universe to denote the dynamic development of our space. Mainly because even scientists are comfortable using this specific wording to describe the new discovery made by the James Webb Space Telescope. The fact that the universe has stopped expanding is both unnerving and inconsistent. with our previous theoretical knowledge of this perplexing phenomenon. So what do we make of it? Let's get right into that. To grasp the extent of the implications, we need to go back to our current investigations of the universe. Back when the universe was conceived, also known as during the Big Bang, the universe was smaller than a single atom. From that point forward, the universe has been expanding outward ceaselessly. At first, it expanded outward at incredible rates, but as the universe grew older, it continued to expand and stretch more. This is the moment everyone thought would last forever. All things considered, if the Big Bang was a beginning of sorts, we should expect a corresponding end. Our theoretical knowledge thus suggests that our universe is set on a singular path of expansion, with no possible likelihood of a slowdown. In other words, we were certain of the ever-expanding nature of the universe, and that idea would have allowed us to figure out how and when the universe would end. The James Webb Space Telescope shatters our expectations of the universe's expansion. Priority straight, JWST's data reveals that the universe has stopped expanding. The new images the James Webb Telescope has captured suggest that the universe's expansion has significantly slowed down. If anything, the universe may not be expanding at all. How exactly did this discovery come about? Well, with the latest images, scientists have uncovered that the light waves have been apparently bending as they have passed through existence. The very bending nature of the light shows that it is space that has stopped growing. The new images reveal something far beyond what the Hubble Space Telescope has achieved. Our previous data was based on Hubble studies, and consequently, it didn't uncover the most important aspect of the universe. The new images have shown that the universe is essentially bent. This extraordinary discovery, therefore, shows that the universe is a circle, and our very existence, including reality, is wrapped inside the circle. With this, another major advancement is the light that has reached the new telescope. The more we look at the images, the more evidence we have that the theory of prehistoric cosmic inflation is both true and outdated. It is true because the universe began at one point, and it has been expanding ever since. Yet, it is outdated because the expansion of the universe has been mostly exposed with JWST's new data. If we focus on the data, we see that the universe, also known as the round point, has stopped expanding. Furthermore, that very nature of the universe suggests the most likely fate of the universe's end. As we said, the universe was made with a Big Bang, but we have never stopped to consider what would be the exact nature of the universe when it closes. Researchers have uncovered the possibilities of how the world ends, and fair warning, it's going to end the same way it started. The expansion has halted, and what happens next is that the stretching of space would also slow down. The new data also reveals the possible end, which is the Big Crunch. We know it's a lot for anyone to explain, but JWST is allowing researchers to observe the mechanisms of the universe. By doing so, we are now aware of the universe's direction. Instead of accelerating the expansion, the universe has stopped expanding. And thus, with time, this curve, or rather, the circle that holds our universe, would steadily implode. This hypothesis isn't new to scientists, but it's only with the James Webb Space Telescope that we have the evidence to confirm it. Imagine it as a round trip. Our universe has reached its peak of expansion, and soon enough it would start collapsing on itself. This collapse is the end of the universe as we know it. The James Webb Space Telescope is an astounding creation that is paving the way for how we grasp the universe. The latest pictures from the telescope reveal that light is bending at the edges, which means our universe has stopped expanding. Furthermore, it also implies that we're closer to our ultimate end than we naturally thought. Whether this will happen in the next couple of hundred years or a few thousand years is impossible to say, but for now, our understanding of the universe has reached an unimaginable stage, which, by the way, is really unnerving.